Okay. Because these questions, method of undetermined coefficients, take a long time to solve. Sometimes I might just ask you, what's the appropriate form of yp to use when you're solving this by method of undetermined coefficients? That's all that's all this question is asking. It's not asking you to determine the unknown coefficients. You just stop right before doing this. Once you start trying to figure out the coefficients, it gets really, really tough. Okay. All right. So let's try to solve this. First, you want to find out the yc because you want to check for duplication later. Okay. So let's find the characteristic equation. That's the characteristic equation. And we're going to solve the characteristic equation by factoring. I think it's, what is this, plus 5 r minus 1 equals to 0. Okay. So you can factor this as 2r plus 5 r minus 1 because 5 times r and negative 2r adds up to 3r. 5 times negative 1 is negative 5, and then 2r times r does give you 2r squared. Okay, so you know how to factor trinomials like this, right? So let's say you factor this. You get the values as r equals to, this is 0 when it's negative 5 over 2, and this is 0 when r is 1. Now what does that tell us for yc? Yc must be c1 e to the negative 5 over 2x plus c2 e to the x. Now let's try to figure out the appropriate form of yp. Okay, you first want to write it and then later check for duplication. Okay. All right, so first of all, I have x times e to the x, so I must have x times e to the x, right? But then if you differentiate this, what do you get? Using the product rule, you'll get just e to the x by itself and another one which is x times e to the x. We already have the x times e to the x, therefore you would need to put another e to the x. Okay, so this will be created when you differentiate this. This will be one of the terms that will be created when you differentiate this using the product rule. Okay? So I need to put a here and b there. Okay, and then how about sine x? If you need sine x, and then what's the derivative of sine?
Cosine.
You get cosine. Okay? So you need both sine and cosine. Okay, how about the cosine x? Well, we already have the cosine x, right? And the derivative of cosine is negative sine, so if it's already used, you don't need to put anything. Okay? So that's not necessary. Okay, now what about cosine 3x? Should we include the new cosine 3x, or are these enough? Yes?
You should include it.
Okay, what's the rationale for that?
Because there's a 3x instead of regular x?
Yeah, so you would say that cosine 3x is different from cosine x, and therefore you should include it. But the correct mathematical way to say it will be that cosine 3x and cosine x are linearly independent. Okay? So they're different functions. Okay? If you wanted to check that, then you can just put these two into a Wronskian and calculate their Wronskian. You will see that they are independent. The Wronskian won't be 0. Okay? And therefore, if you have cosine 3x, you definitely need to put a cosine 3x. But then when you differentiate cosine 3x, you get
Negative.
something times sine 3x, right? Cosine will turn to sine 3x, so that you need also. So these are everything that you need in order to create this. Now you have to check for duplication. Is there any duplication? Where?
Yes.
E to the x in the complementary solution is duplicated here. Okay? And that's bad because if you plug this into the left side, even before getting something meaningful out of this will be just gone, right? Therefore, every time you see a duplication, you would multiply by x. But then, here's another funny thing that happens immediately when you multiply this by x. What do you see?
Duplication.
A also has x times e to the x. These are the same thing, right? And in that case, what you need to do is you also have to multiply another x. Okay, so this is like trying to resolve two duplications. Okay, so when you see a duplication, multiply by x in order to avoid the duplication. But if multiplying by x produces another thing that's duplicated here, then you should do that. Okay, so that's very important.